Okay, David, Professor Ho, and colleagues, and I'm very pleased to be invited to give a talking here in this occasion. Since this is a workshop to honor Professor Ho, let me also put a little bit personal note on this Professor Ho's research and my little relations with Professor Ho. I went to University of Toronto. Unfortunately, I went to business school. So at the business school, they ask you to take lots of courses in addition to comprehensive, major, whatever. They ask you to take 2 minors, and each minor which requires 2 courses. So since I was graduated from engineering, and I took 2 engineering minor. One is in EE, and the other is industrial engineering because that's close to me. And in EE, I took, Professor Concentra's just mentioned. I took Professor Wallum's supervisory control as my minor, which is a 1-year course, 2 semesters. And first semester is a supervisory control, and second semester is other methods in discrete event systems. So my first year, I still remember my term paper is, because we all need to write the term paper, I choose the topic, colored Patrinet. I still, okay, in my second semester, when, Professor Wallum introduced other, things, which gradually, I get interested with IPA, and actually my dissertation is heavily IPA, and I also have 1 IPA paper appeared in operations research. Of course, it again take quite some time. It took 5 years to be published in operations research. So that is academic, my academic, early academic work. I first know Professor Ho in 1991. Stan Gershwin organized a workshop on manufacturing systems. David was there, Lincoln, New Hampshire. And I drove to New Hampshire with XYZ, Shun Yuzhou. 2 of us drove there. And we talked to you, and you said to us, write down your Chinese name, and we remembered you well. We did. I do not know. So we did. Both of us wrote our Chinese name to you. It seems to me, started from that point of time, you remembered me. So therefore, when you went to Tsinghua University in 2001 to start with the Chan Professor group, and I was so lucky and be part of that Chan Professor group. So my colleagues talked about financial things and among many other things. Some other colleagues also talk about children education. I just want to tell one little story. I was planned to, when Yuma raised the question, I was thought about should I talk about that at that time. But when I saw your grandchildren was there, I said I better shut my mouth. But now I can talk because they are not there. They're not here anymore. So in addition to the contribution, great contribution on the academic side, and Professor Ho also had a good life. And he talks about his best investment, probably more than once with me. And he says his best investment was the house in New Hampshire, and where you get a few, Harvard professor made that design, and start from that point of time, and you took your children to New Hampshire during the summertime. So when you have grandchildren now, they started to book you about their house. You don't have to go to see them. And they come to Boston to see you. And you say that was the great investment. If you want to invest something, that's great investment. Now I have 2 boys. If I needed to make a phone call with them, I first need to send a message. Are you free to call? I need to make an appointment. So Professor Ho, the children, grandchildren come to him. So my financial professors, if you want to look into the investment, you're definitely able to learn from Professor Ho. So since David asked me to give a talk, and I thought about it, how can I choose a talk? I choose this one purely because of the main leading author of this paper, Xian Yang, is a student of the Stephens. And started from joining the Stephens, I have supervised quite a number of the students. And I'm very happy with my experience with the Stephens at Tsinghua. So here, this talk is about the performance discrete choice model, which has been studied, in a considerable volume in the economics and with considerable application in marketing and operations. People also got involved, and that belongs to a class so-called discrete choice model. So basically, customer choose one or the other product, make discrete choice. So that's discrete choice model. And that pioneer work was done by Daniel McFadden, and he was the Nobel laureate of 2000, got the Nobel 2000. So this is a little piece of the work we did recently, and which construct Xian Yang's main body of the Xian Yang's Tsinghua PhD dissertation. Okay, here is the things which we're looking into that. So when we started those things, again, we started, I'm not trying to say we started with the problems. We do both. We had a little theory, and we made progress on the theory side. And afterwards, we said we better to have some story to tell, and that is a story. And in Hong Kong, there's a magazine. Hong Kong has a consumer, Consumer Association, and it publishes a monthly magazine called Choice. So Consumer Association, they are, from time to time, they speak out for, small consumers. For example, and every month they publish a testing, so-called testing result. And here I give you an example where it's about mobile phones. And in terms of the mobile phones, and they did extensive study in terms of what is the quality of the telephone conversation, what is the quality of the camera, what is the quality of battery, and what is the quality blah blah. Okay, so therefore what they do is they measure those functions with so-called starting systems. If the particular thing performs well, they give 5 stars. If it's not perform well, they're giving 2 stars, 1 star. So afterwards, they come up with sort of a formula giving a different weight. It says the voice takes 25%, and the message takes a message taking 15%, network function taking 15%, photo function taking another 10%. So therefore, they come up with the individual score of each item, and then they have a weighted average. They're putting this thing into 5-star systems. And look at that. Next to those 5-star systems is the price of that particular mobile phone. And they also do, every month they're doing this sort of analysis, and which, again, looking into this camera as example, they do the same. And what they do is looking at functionality, and next to the functionality, they say there's a price. Of course, probably some product with good functionality, the price might be high too. So that introduces us to think about how the customer to choose the product from the market. The original work of McFarland is about surplus utility. So basically, you have a reservation price compare with the list price of that product. If the listed price is lower than your reservation price, and you say the customer might choose that product, and we say just 1 second, and you probably want to, because the price tag, if a $1 difference between a product that is $10,000 compared with the product like $10, the customer is going to behave differently. So therefore, we say you probably want to looking into the ratio of the functionality and the price, and price performance ratio comes from this place. But again, this is not unique. And if you are going to internet shopping, and they usually in Chinese they're also giving you something called 性价比, performance price ratio. And I can continue with this in terms of airline. You buy an airline ticket, and they come up with 2 dimensions. One, it's the price, and the second is how long the flight is going to take you. And sometimes with cheaper price, and you probably need to make sort of connections in the different places. So they say if you combine with these 2, one is the price value, and the other is it's the duration of your flight, and they say that is a smart value. I can continue on with this, but what I'm trying to say, and when we make choice, we make decision, we probably not only looking into reservation price and the ticket price. We're looking into multi-dimensions. Okay, so here is the research question we try to answer. Okay, how do customers behave on the performance price ratio criterion, and how this behavior is going to affect retailers' decision making, and finally, we want to say whether there's a theoretical model which can be supported by the real data. So that is the thing which we want to looking into. So specifically, we're looking into this number of the things. And what do we try to do? It's first introduce the performance and the price ratio utility. And afterwards, we want to sort of investigate what is the probability for customer to choose a particular product by recognize the customer are always a different preference, and customers, they are all different. And we also introduce the stochastic the feature on those choice decisions. And afterwards, and because when the product in the market, the main competition among different retailer, it's price. How the retailers makes use of their price decision to compete in the marketplace, and we want to identify whether there existing equilibrium, the game setting with the equilibrium, when the equilibrium can be derived. And we want to also further to looking into whether those price decision and price performance ratio affect this equilibrium. And put it the other way, and what is the best way for the retailer to competing with in the marketplace with the performance, its design, the performance, and the price. Lastly, fortunately, we are able to access a huge data set. That probably is the advantage of doing research in Hong Kong and in China. And we are fortunately able to access the entire China TV market data, and which consists with thousands of cities, 10,000s of shops, and we have huge data to deal with. Okay, so literature-wise, and actually I probably already mentioned, and which McFadden McFadden first derived their existing equilibrium. Only existence, not explicit characterization of the equilibrium. And that is come up with something called the multinomial logical model, and which customer choosing between discrete the product. And afterwards, there's a considerable piece of the work which in the recent literature, and I would like to mention the work by the Gallego and his student. Both of them conducted that relatively general model on this discrete choice, and which extending utility function to different forms. So this is the problem setting. Reminding me how much time do I have? Okay, I try to manage this. So here we have K retailers, and each retailer has one decision to make because the functionality is already done. When the product is in the market and the functionality is done, and the only thing you can do is choosing in terms of the price. And a customer is choosing the product among those K plus one options. And customer has one more option, that is we don't choose anything. And the customer has its utility functions, and which associated with price P1 to price PK. And U0, that says reservation utility. Basically, I'm not in the market, I'm not doing anything. So therefore, the performance ratio, which we can, in terms of the performance ratio, we write as follows. We say the utility function, the alpha I is the functionality, it's the summation of the functionality, like that mobile phone things. It's 20% of voice plus blah, blah, blah. That's the functionality. And it divides by price Pi and to the power of gamma I. Gamma I is the sensitivity. And that measures a particular product where how much efforts the customer putting on the price versus the functionality. Okay, so the Z(I) is the stochastic, is the random factor of a particular customer, and which try to characterize those unobserved attribute among the customers. So therefore, with the reservation price, if we do denote the reservation utility as gamma 0, P0 to the power of the gamma 0, and we have all the parameters set it up. So the first thing we try to do is try to characterize the probability of the choice, a particular customer to choose between product 1, product 2 to product K. And that is very much leveraged on the McFadden's existing work on this C plus utility. So what we do is we say the probability of the customer choose product I, it's because the utility of the I larger than all the UJs. Okay, if we substitute with that utility function, and very quickly we derive the probability can be characterized as zeta I less than alpha I times Pi to the power of the gamma I, and divided by AJ times PJ to the gamma J's power. And so the probability, if we can choose looking into the joint probability function, we can further derive the probability. And McFadden using an additive utility function to deal with that stochastic component. And in his work, and he where if you have exponential the Gumbel distribution, and with this multinomial logical model, the probability can be written as follows. And what we do is we looking into this multiplicative utility function. So we write this utility function as I already mentioned, and if we take a transformation and we take a log form of that utility function, we can write that again back to a summation form. And if we define our observed attribute of the randomness is again log z equal to zeta, and that follows type 2 of extreme distribution of random factor. So under that setting, and it is not too much difficult for us to derive the probability of choosing a particular product. Okay, given we have a non-purchasing option, and the probability it can be written as the value of PI divided by summation of the value of the PJs. And we can further derive the probability explicitly, and that is written as this form. With the probability in place, we can continue, and that continue we want to looking into what is the expectation of the revenue. The revenue is a PI, the price, times the probability. And start from that point of time, if we are write all of those individual revenue functions, and if we choosing put the PI as decision variable, and we forming a game setting, and each individual retailer try to adjust its price, try to on one hand increase its market share. That is related to the probability, the choice probability. At the same time, they want to optimize the expected revenue. So with that game setting, I skip with the detailed the mathematics. So what we can do is we can find, they are existing the equilibrium and the price, equilibrium price for each product, which we can write as follows, and this gamma I is the sensitivity for the product. And the market share, and which it also can be characterized as gamma I minus 1 divided by gamma I. So the gamma I and actually play an important role in terms of this competition solution, and in terms of how we believe for different product, and you probably have a different gamma I's, and that is sort of the testing, one of the testing item when we do a data analysis. So it turns out, so the explicit, when we know the explicit, when we know this equilibrium price and the market size, which can be characterized as the gamma I minus 1 divided by gamma I, and the market share, which is the probability divided by the rest of probability. And those things are all can be characterized. Okay, and we also know in terms of how this sort of the competition result is affected by the performance. Okay, by the performance. If one increase the performance, price goes up, and the market share doesn't change, because market share, as the expression, is only depends on the gamma I, the sensitivity of the product, and of course the revenue changes as well. And we also know what if one party increase the functionality, and what is the effect on the other party. So basically, if you look at the this, if one party increase its functionality, and in terms of its influence on the other parties of the price and market share and the revenue does not change, because that depends on the sensitivity of the product. So we can further identify few quantities, and which defines where, and this define this gamma I, which is meaningful in the competitive the setting. Let me go through with the data which we happen to have to access. And this data, it comes from Allview Consulting Company. And again, like Professor Ho mentioned, to access this set of data is because of the a consulting project. And a TV company, Skyworth, and which probably is one of the largest TV manufacturer in China. And they want to do forecasting. And when they use their own data to do forecasting, nothing happens. When I say nothing happens, because when they use their data to do the forecasting, and they don't have any, sort of or remote accurate forecast. What their data have, and they don't have a data to record when a particular product is sold, and the data you are having is on which day the product was shipped out. So if you base on the shipment data, if you want to do demand forecasting, it turns out to be difficult. But when they use the customer data in addition to their shipment data, when they use the market data in addition to their shipment data, and that forecasting became believable. Okay? So, I just like Professor Ho mentioned, and I don't want to stop by consulting worker and provide with the company with a solution, and we want to look into the data more closely. And that is I insist to my student, and actually Xianyang says we already have all the theoretical result. We don't do this, theoretical, the empirical test, and because this is boring. I say no, you have to do it. And my another student, Shoyi, is here, and he probably can be my witness how hard I push him to test with the data. And so I just want to mention in terms of the scale. The largest set of this data. There's are reasons, and Yang does not want to do it because there's too many to deal with it. So what do we do? I said, okay, that's easy. Let's go easy. We don't do everything. Let's only do 5 big brands. Okay, so now Yang agreed to do it because that 5 big brand is already considered about 80% of the product. So we do that 5 big brand. And in terms of the monthly data, which contains price, how many units sold, and what is the market share, and what is the TV models, and a TV model contains many components, including size, definition. So this is interesting in a way which when we look into the functionality, it contains multi-dimension. But we also want to know to a certain extent when the customer choose those brand and which is the most important phenomenon and the customer want to looking into. And we do get this answer though. And here is the demonstration of the data. When we look at the market share, you see those 5 companies. Skyworth, Hesing, TCL, Kangja, and Changhong, they all sold large number of the product. And actually those 3, 1, 2, 3 are market leader, and those 2 are sort of followers. And if we're looking into the price data, average price, and which change because of in China, the price change just like this. Okay, so what do? We can look into what is the average price and what is the average the sales. So when we know the average price, remember, and that is when we consider that is market getting into equilibrium, and we can plug in with the equilibrium function, and we can get to know. Remember, I have price, equilibrium price equal to a function of the gamma, and I can derive the gamma. And further continuing on, I also can, because it also gives me in terms of the market share, and which help me to derive what is my alpha, that is functionality. So, okay. I stop. So basically what I'm trying to say, and that data fits the model very nicely. Okay, of course we are continue with some other development, looking into other models, and Xiaoyi is we are getting second batch of the data, and which contains the information about online and offline. So now we can further continue to test the discrete choice model in terms of with the sequence. You know, if I needed to choose buy from from the real store or buy from website, and we have some good result comes up very soon. Let me stop in here. Thank you.